Hey everyone, this is Martin. I am back, and I think this is video 4 of the devlog series on building a first-person shooter engine from scratch with C++ and OpenGL, and basically following the course on Udemy. And this is sort of like a recap. It's not a tutorial, it's just me going over what I've learned, and by going through these videos and trying to explain the code, I'm basically trying to explain it to myself as well. So it's that's kind of the goal here, is to share what I'm doing and also to try and uh, cement in what I've learned. So let's just show you where we're up to. But it's basically full scene loading now, which was a big step. It was a big couple of chapters that just went in. So this entire scene is now being loaded via a scene file with a .sc extension. Now the extension doesn't really matter at all, but this big block here doesn't have any physics on it, but this small block does. As you saw at the beginning there, it was falling down. Still got animation. The player collides with that block as well, and also collides with the floor. So, but instead of this all being loaded from code in a C++ file, like in the level file or I think it was the game.cpp file originally, this is all now being loaded from within a scene file. So that's pretty cool. So let's take a look at that first, and we'll see what we can see. Again, I'm kind of rusty on this. I've coded along with the video on Udemy. The link is in the description, by the way. And I've understood most of it, but some of this I'm a little bit sketchy on. So it was like an hour long, or 2 half-an-hour videos that I went through, and I coded along with it, basically typing everything out from the beginning, not copying and pasting. So it did take a while. The guy did paste in a couple of chunks of code, like for example this JSON here. So yeah, you have to forgive me if this is a little bit sketchier, if I don't understand a couple of things, but hey, that's the whole kind of point of these videos, really, is for me to try and understand more. But anyway, this is the scene file, so this lives in the scenes folder. So we've now got assets loading from materials, model folder, shaders, etc., and now scene as well. So we've just called this scene.sc. If I just collapse a few of these, we've got root objects, the name of the scene, what object the camera is supposed to be attached to, and then the root game objects as well. So this is objects here. I'm again trying to translate this to kind of Unity terms, just because that's what I have experience in and that's what I understand. But we've got objects here, so root game objects. So if I just collapse these again, if I can, 4 or 5. Oh no, I think I've collapsed maybe too many here. Oh no, that's fine. That's light. Yeah, so there we go. We've got 5 objects. So pretty standard kind of JSON stuff. So the first one, we've got name, position, rotation, scale, component, and mesh component. So this is the one that's kind of elongated along the floor. You can see it's got like this Z of 5 here. And so this is cool. Originally this was just in the C++ file. If I go to the next one, main player, there you go. So we're defining the name of it, the type, and this is a built-in type as well. Oh no, this is a custom type, if I remember right. I'll explore this in a moment when I'm sort of digging through the files a little bit more. But the different components, so this is, again, similar to how it would work in Unity. You slap on like a component on a game object, like in this case a camera component, and a controller component, which gives it the physics, and then a list of children as well. So the code that I'll look at in a moment loops over any children and also instantiates these as well. So and then finally we've got, I think it's a light in the box, the ground, there you go. So mesh component, and it's also a physics component, and it's a static one. So you see we're defining the all of the components and all of the values of those components as well, so the properties of them. So yeah, I won't go through this much more, but you can see pretty cool kind of standard JSON stuff here. What I can do is possibly just to kind of demonstrate as well, if I go to not the main player, not the ground, I was looking for the object collide. I think I should just be able to kind of double this up if I was to just do this. Now, I've not tried this before, so let's just see what happens. Hey, And if I go down there, and if I give this another name, object collide 2, now hopefully this JSON is all okay, and I've not made any kind of comma errors or anything like that. Oh, there's one comma error down there. That should be fixed, I think. Does that look okay? I can't tell. Components. I'm not sure if that's reading it correctly there. Maybe I've done that a little bit wrong. Let me check the... No, that looks right. I don't know what is the problem with that there. Maybe I've pasted too many over, or maybe it's just... was it Visual Assist just screwing up? Let's click on play and let's just see what happens. Hey, probably doesn't work, but hey, give it a try. Oh, there you go, two blocks. Boom, and it worked. All right, cool. And I'm colliding with both of them now as well. So that's exactly what I was hoping would happen. So there you go. That's just a little example there of how the scene file would work. So with an editor, like in Unity, you would obviously the scene file would be constructed from you putting stuff into the editor in the scene, and then this thing would get generated, and at the end it's just loading from that file. So I think, do I need to step back now, or was that everything? Sorry, I'm lost. It's late, everybody. You'll have to bear with me. So it's like 11 p.m. and I'm absolutely shattered. But hey, I wanted to do something tonight. I wanted to get some kind of learning or progress on my side done. So, all right. Anyway, so game file here. This is or game CPP. This is the. If you remember from a couple of videos ago, this is the client code. So this is as if you are the developer writing. So this isn't part of the engine. But all we're doing here is saying scene load and then giving it to the path to the scene. And this is all relative to the assets folder up here. Then it's just calling load and then the scene name. So if this is like the meat and bones of it all, really, is this load here. So we've got the path. Yeah, grabbing the contents. So basically just reading this entire scene file. We've got this load assets file text, which is the sort of the resources manager. I think I might have explained that a couple of videos ago, but yeah, allows us to just grab all the text, and then we're passing it here to JSON using this Nolman library. I think that's how it's pronounced. Forgive me if that's wrong. Checking that it's not empty, of course, and then we're creating the scene. Grabbing the scene name as well here. So that's that top level bit of info here that we've got this key value pair up here. And then the big sort of chunk of it, the main kind of chunk, I think, if I remember right, is here. So this is, do we have an objects array? So if I go into objects here, well, you can see it right there. It is an array, and it's a list of objects. And if that is the case, then we're going to loop over all of these, and we're going to load them. So get the values of loaded JSON object, and then null pointer equals null parent, because these are root objects. So let's go into load object. You'll have to forgive me if I'm speaking a little fast here or a little slurry, as again it's kind of late here. But I've added comments as I've gone, and I like to be pretty comment heavy in my code, like my personal code anyway. If I'm writing games, sometimes like personal projects where I've written a lot of iPhone and Android games over the years, I make it very comment heavy, like book-sized comments basically, and they have helped when I've come back to it. So. But loads an object from parse scene file, game object or GLTF object, and GLTF is like a model format, so similar to FBX or OBJ, and it happens in this order. So create the game object, read its properties, and then read components. So this is the game object itself has properties. So I think that's things like name, and then it would be position, rotation, scale, because every game object has to have a transform. I think that is true. Everyone has to have a transform, and I think it does read those as part of the properties, the position, rotation, and scale, and then read the components and the properties of those components. So let's go down the list and just see what we can see. So first grabbing the object itself, so the name, and this is for each object. Sorry, if I just go back a little bit because I'm losing my trail here. Yeah, so all of the objects in the list of objects here. So basically, every single object in this array of objects passed into this load object function as like an individual object. Okay, so let's go to this again. And then if it's got a type, if object contains a type, then yeah, we're either going to load it as a GLTF if that is indeed the type. So that's kind of a reserved keyword that I've mentioned there. Else we're just going to create it as a game object, create a custom user type. That's if it is given a type, but it's not got, but the type is empty, or it's not GLTF in this case. So let's say in the example of the player that I think it was the third one down. Nope, second one maybe. Yeah, so type player. There you go. So this would be a custom object where we're adding our own custom components, not custom code, but we're adding. It's not a game object and it's not a GLTF file. It's a player with different components. So if it's a GLTF, we just read everything that was on the GLTF. So animations, child game objects, components, and so forth from the GLTF. If it's one that doesn't have a type, then we're just reading it as instantiating it as a normal game object, like a standard one. And then this one though, we've got a player type. So we're loading those components that we've set here, and then the children. So let's go in. Yeah, so GLTF there. We're setting the parent, setting the name as well. In this case, the parent was null as it's a root object. And then if no type declared in the JSON, then create as a standard game object. Okay, so that is. I think we went into this before, maybe, oh boy, a while ago. It might have been in a video or two before, but create the object, so object equals new game object, yep, and then setting the parent. And again, this is kind of, like I say, Unity land. Like we have new game object as a callable engine API within Unity. We can set its name. We don't have, I don't think we have a set scene within Unity, but this is kind of like reads a little bit like how we're doing things in Unity. And again, I'm just trying to make that connection between Unity land and then C++ OpenGL land here. So let's go back. There was more complicated stuff down here, I think, but here we're creating the objects. That's the main point. That's the main chunk of this sort of like code here, and the thing that I want to kind of explain. So that's where we're loading the game objects. Like I say, point one here, just create the objects. And I think the properties part was the stuff that was a little bit more complicated, I think, or maybe the components part. So read the transform data, which is common to all game objects. Yeah, so that's what I said before, is for all game objects, they all have basically a transform, a position, rotation, scale, and we're doing game object set position, set rotation, set scale. So if I just take a look at that definition here, yeah, the getters and the setters, and this in this case it's just a setter and position. I'm not going to dig into this one. I think it was kind of covered a while back, but I don't want to go too deep into the weeds. I do want to keep it kind of like surface level around how this scene file is loading things. But again, we're just passing the JSON from within that game object's children. So if I go to, just to elaborate on what I'm talking about, there you go, position there. And I think the other one doesn't always have to have a rotation and scale. Again, we've got the position there for the ground, and I think there was one. There you go. So object collide, position, and rotation. And I don't know if the light component has anything but position. Yeah, just position there anyway. So if it does have a rotation value, it gets passed there, and then scale as well. Now this is the one which was load game objects, game object load properties. So the JSON object is the, yeah, so that would be in this case, say like the player. The JSON object here is basically the JSON representation of the player, or the falling box, or that static box on the ground. So if I go to load properties here, let's see what this does here. User define custom. Oh yeah. Okay, so right, that hasn't yet been defined. Probably going to be coming back to this. So user defined custom objects that can override this. Yeah, I think so. That I'm thinking of what the kind of big part of all of this was, where I was struggling a little bit to understand, to be honest. But hey, let's see how we get on. Load game object components. So if the JSON object contains components, which in this case it does for most of them, like there we've got a mesh component on the ground, and that's an array of objects, a physics component, components for each component in components, string type component value type. So in this case, let me take a look again. Yeah, so let's say mesh component. So there you go, there's type, and these are built-in types, as we'll see in just a moment, I think. So component factory, create component type. So this is load properties. Yeah, so this was a lot of this. This was a lot of the past two classes that I went through, was this component factory, get instance, and then create component. So if I go into here, and this is where I got a little bit kind of not clear of what's going on. So I'm going to have to dig into this a little bit more, like off camera myself at some point. I don't want to Google around in front of everyone and spend the next 20 minutes or an hour in. But what we've got is a component factory. And there you can see we've got the singleton accessor, get instance, and then as you saw a moment ago, we're calling create component. Now this part we've got register creators.find, try to find the specific creator. So this creator part as well, this is where I got a little bit confused of where these creators were getting created. So if I go to this one, and I wonder if it was at the, this gets generated at the beginning, I think, this register component, mcreators. I think this might be registering the default or the built-in components, if I remember right. If I go to find all references for register component, because you see this is where we're adding it here. Where was it getting called? Register component. Right, so register component gets called down there from this macro. So it's right, so for each component type we create, so component class. So let's look at mesh component here, why not? Let's see how that kind of all ties together. Source components, mesh component dot h maybe? Yeah, so there you go. So component, and again, that's this component, mesh component is this big macro here. And then what we're probably calling is register component.h create component. Yeah, again, like I say, you have to bear with me, everyone. I'm sorry, this is so rough. This is kind of how it goes for me, and probably most developers as well, sort of just scrolling up and down trying to make sense of what the heck is going on. It's not like the hackers movie or anything like that. So we're registering the components somewhere. If I find mesh component again, I'm pretty sure it gets called for every built-in component. Register is called. If I find references for this, see, I don't know if it's going to find it from the macro. You see, that's what I'm not. That's where I'm not sure on kind of like how macros work exactly in C++. If I go to, I think it might have been an engine. Maybe engine init. Maybe maybe not. This is engine init. No, this is not it. Yeah, you see what I'm kind of looking for here is this hey, for all of the components, like for example this mesh component here, where does register get called? And once it's registered itself as a component, it's basically generated a component creator for that component specifically. So here we've got, generic type T as a template. So it only gets, this code only gets generated if it's used, if it's actually called. So in this case, like a mesh component here, we'll register in the component into the creators. And then what we're able to do is when we call create component specifically from this create component here based on the type, then we create the component. Yeah, so try to find a specific creator. Yeah, so we're finding the specific creator because we added that when we registered the component. At some point I need to dig into where that actually gets called. But hey, let's just skip past that because again I'm going to be digging for a while probably. And then we create the component. So if I go to, yeah, so create component, override, and I think this, where was that create component? Was it down here? Create component, iterate a second. So the value, try and find a specific creator for the type and name and create the component instance if found. Yeah, so we create the component and then again I'm not sure where this lives exactly, whether it's just like recursive call in itself or engine component creator base. There we go. Component creator base, is that up here? Component creator base, if I go into here, yeah, that's all. These are all in this single file. Component creator base, config, yeah. So creating a new type T there. In this case, the mesh component. Yeah, sorry, I'm getting a little bit mixed up. I'll have to like dig into this a little bit deeper just to understand the order of execution of what's happening here, because I'm kind of going up and down. I think it's this one here that finally gets called. We're returning a new type, in this case the mesh component, and so create component, and then we're returning that component, else we're returning null. So in this case we're calling create component from here, the scene.cpp file, checking that the creators do exist from when they were registered, when the engine first started. I think I need to check that. And then if it does find the creator, then we create the component, which basically calls this here the create a template for a concrete type. There we go. So this sort of like factory system that we've got going on here returns the new type, and then that passes that back to scene.cpp. So I think that's roughly what's going on. If the component was indeed generated, so the next thing we want to do is load the properties. And I think this is where, if I go to the, yeah, it was also in the component.cpp. What I'll do is, was it down in here? No. If I go mesh component.h, yeah, you go load properties. So, oh, this is the one that gets overridden in each of the classes. So if I go to load, I think load properties is defined in here somewhere. There, load properties, there you go. So it's virtual. It gets overridden in the concrete implementations. So in this case, in the mesh component, we've got load properties. And if I go to the definition in here, I think it should here. There we go. So this is, I'm just using mesh component as an example, but it works for the physics component, for the light component, and all the other components that we saw in the scene.sc file here. We're checking, hey, is it containing materials? So let me get rid of this at the bottom here and move this down a little bit. So does it contain a material? get the path of the material. So let's say in this case we've got in the mesh component. Let's go down the list and see if it does indeed do this. Yeah, so here we're looking at the ground. We already passed the position as part of that base game object type. Each game object has a position. The mesh component, the material, there we go. So we're checking, hey, if it has a material, which doesn't have to by the looks of it, but if it does, then get the path of that material. And in this case, we're getting the material /bricks.material. And if the material's loaded, then set the material on this mesh. So the mesh component itself contains a material slot. If I go to the mesh component, set material and material, there you go. So, and this, I need to sort of dive back into this as well. So mesh component, set material, and how this all works in terms of rendering as well, because it's getting pretty chunky now, guys. It's getting pretty big in terms, there's quite a lot going on here already, which is good. I'm kind of learning a lot, and hopefully you guys are picking up stuff as I go along as well. But let's just go back, load properties. Oh, sorry, no. Set material, load properties. If it also contains a mesh, then what type of mesh I think it is, type equals type. So in this case, let's see what we've got. It should be a box, I think. Mesh component type box, there you go, and then XYZ. Mesh component box is the default if there is no type, so use the type. If not, just call it box. And then generating the box, the mesh, the extend. So that's the visual representation, the mesh itself, not the physics object. So the physics object is a separate component down here. That's the physics component. So we've handled the, if we look here, we've got the mesh component, and the mesh component has a material and obviously a mesh as well. So, and then within that materials, if I remember brick.material, that contains the texture, the path to the texture as well. I am curious because it has been a while. If I go to materials brick.mat, let's take a look. We've got the shaders that it uses, and base color texture, and then the texture is brick.png. Yeah, so it references this brick down here. Okay, cool. That's a nice little refresher for me. So maybe just extending this example a little bit further as well, just to kind of make it a little bit more concrete in my brain anyway. But we've got the components of this ground. We're looking at the mesh component right now, so that's that object there, which is in the array of components. Next, if we look at the physics component as well, it should do the same thing as well. So if I go to physics component.h, that one there, again, we're using this macro here from component.h, which is down here, where we've registered the component as well. Again, this is when the engine first starts and it registers all built-in components, I think. Again, I'm going to have to confirm that, to be honest, and I'll do that off camera. Physics component.h, what we've got, same thing again. So once it generates the component, it creates the component, then we load the properties of that component, which is in this case load properties here. So we're checking, does it have a collider? And if I go here and check again, so we've got physics component. Yeah, we've got two things. We've got a collider and a body. So physics component. Yeah, the collider. If it's a box, get the extents from the value XYZ. Again, these three values here. So it's reading the, passing the JSON and getting those values, and then creating the box collider. And then if it's a sphere or a capsule, it's doing that as well. And I think, if I remember correctly, these are wrappers for bullet physics instantiation stuff. So if I go to that definition there, extends collider, Yeah, box collider. Let me just find sphere collider. Can I go to the implementation? Go to not definition, sorry. Oh yeah, no, that's right. Collider.cpp. There you go. So BT box shape. So BT is bullet physics. So you can see that our collider class here is a wrapper for bullet physics stuff. So passing the extents, and then it creates the box, adds that to the physics world, and then we update that world with a physics tick to say, hey, recalculate, simulate the next step, basically. So if I go to load properties again, where was we? We were on physics component. Yeah, depending on the type of collider, whether it's a box, a sphere, or a collapsal, we'll instantiate them. And then the rigid body as well. So this is like the collider part, as in the shape. What shape is this physics collision object? And then what type of rigid body? Is it dynamic, kinematic, static in the case of the floor? And then finally we're setting the rigid body. So the rigid body, I think, has the collider. There you go. So rigid body, I'm looking here. So yeah, the type, when we finally create the rigid body, the type, the collider that we've defined up here, the mass and the friction, which we're grabbing from these values here. So mass, friction, and that's being passed from the scene file as well. So that's down there, mass and friction. And finally instantiating it and setting the rigid body. And the rigid body, again, if I remember right, is bullet physics stuff. I'm pretty darn sure of that. It's all like wrappery stuff. So if I go to rigid body, go to definition, there you go. So yeah, bullet physics vector 3, body type dynamic, probably info. So I'm looking up here kind of what this is. That's a big, there you go. So you can really read about this stuff. This is why I love giant comments and summaries. So there you go, BT rigid body. So it's the BT rigid is the main class for the rigid body objects. It's derived from BT collision objects, so it keeps a pointer to the BT collision shape. Yeah. So that's where the properties get read, and then we finally set the rigid body of this physics component. So this is the physics component. So whenever we say component, we're basically the thing that gets added to the game object. And then in my mind, again, the component is the thing that lives on the game object in Unity land, I'm thinking, and then from that you get fields. So in this case, the rigid body field on the physics component. So okay, cool. That's a couple of examples within the scene.cs file. So let's go back to where we was kind of earlier, which was in, I think it was scene.cpp, load properties. Yeah, so we loaded the properties, whether it's a mesh component, a light component, as we just saw right there in a physics component, and then the game object that we've instantiated, we then add that component. So that sort of drilled it in a little bit for me. That load factory stuff and that macro and the register components and stuff, I'm gonna have to dig into that a little bit and just to understand it, because I roughly get it, but I need to know where that kind of lives, because for my own sanity. So check for any children and load them recursively. So yeah, that makes sense. So I think the example that we've got in the scene.sc file here is the player. Yeah, it's got some children, and it's actually loading the GLTF file, which is this model file up here. So is it the Sten gun carbine scene yada yada? Is that right? Scene.gltf. There you go. So I think this is all a big old JSON file, if I remember. Yeah. There you go. Oh, it's huge. Okay. So, and this loads that as game objects as well. You can, I think it gets parented. I remember. So you can in fact just load an entire GLTF file as a scene, and it becomes a root object of the scene. And I think in this case what we're doing is, because it's a child here, so we've defined the children, this carbine gun model doesn't get loaded as a root object in the scene. It gets parented, I believe. So For all children, load the object. Yeah, so in this case, child, if I just go into here again, this actually is, yeah, this is like a recursive call. And I think we get the type here. Yeah, so there you go. So in this case, the gun, that carbine, it would be a GLTF file, and this is where this load GLTF magic that I did a couple of weeks ago. Yeah, so you can see here, again, this is why I comment the heck out of everything. And this, again, was from the video on the course. I just sort of copied the diagram, but into kind of ASCII note format. So you can see each node is basically a game object. So any node is a game object. Nodes contain meshes. Each of those meshes has a primitive, which is a drawable object, if I remember right. And then, yeah, because you can have a mesh with sub-objects, can't you? So you can have a single mesh with, like, you know, I'm trying to think of an example. I don't know, the torso and the legs or whatever. And then you define the geometry and the material, and then that gets created as a mesh component. And all the material information would get passed on to this mesh component as well. So that's the GLTF file, how that gets loaded. And that's a recursive, so it should be, yeah, there you go. So parent load object, sorry, I'm going back here again. So there you go, so parent as well. So the game object that has the children is the parent in this case, so yeah. And then allows for any custom initialization, so game object.init. I don't know if there was anything custom on here. Yeah, user defined custom objects that can override this. So yet to be seen. I think this is going to be next in one of the upcoming classes. I think the next one that's on the roadmap is audio. So I'm going to watch that first. I'm then going to type along with it. I might do that one plus another one, and then I'm going to do another one of these videos and just talk through. But that was interesting for me. The understanding of how we go from a scene file, how it gets parsed, how it gets, how we first load the game objects. As I think, where has it gone? Where has it gone? Set parent? No. Where's it load? I've lost it. There you go. So create the game object, and then read the properties of the game object itself, and then read the components, and then reading the values of those components. Then read components. I'll add a comment separately. Then read components plus. Actually, I'll put it in now. Load components properties. Yeah, so that's what we saw with the mesh component and the light component and so on. But again, this was interesting because it ties in how Unity does its scene loading and solidifies that a little bit in my mind, and how I can eventually grab just a GLTF model. Let's say I've got a scene and I want to build like a little FPS, like a Doom thing is what I've got in my mind. You know, just to build something that's playable. I'd have my Doom level as a GLTF file. So in this case, you know, we've got the player, is it there? So yeah, that would be a root object, would be the scene file. Then I'd also have a main player as well, of course, and then weapons, and then maybe enemies in here, and have those under as a children, as like an enemy parent, and then probably like add in like a custom component here as well. So that's the other thing that I am interested to figure out as well and understand is, so these are the built-in components, the camera component, player controller component, and so on, and those are the kind of things that you'd add in Unity. You know, if you put like a light component on a game object, or a rigid body, or a mesh component. Custom components. So in Unity, when we write our own little mono behaviors, and we've got, say, like, I don't know, this is the player character, and you press the space bar and he jumps, whatever, or you've got press the D key and it deactivates, it's set active false, whatever. How do I create those components and add them? That's what I'm curious about, and I think that's going to be coming down the line. You know, would they be written in? I'm assuming they'll be written within the source code down here, and then they would be derived from the component object. So here we've got like mesh component. This is all of the old code where it was added, where the whole scene was generated through a C++ file rather than a scene file. So I'm interested to kind of look into that next, and hopefully it'll be coming down the line. I'm pretty sure it will be based on the class list. Anyway, that's it. I'm really tired, so I'm going to go and have a shower and then go to bed. If you do want to check out the course, everybody, the link is in the description. It is an affiliate link, just full disclosure, so if you do end up purchasing, then I get a small commission and it just helps support the channel. But so far, I would recommend it if you are interested in low-level engine development, which is, how can I put it, which is similar to how engines like Unity and Unreal work and Godot, as far as I'm aware, and all of those core pieces. So it doesn't include the editor. That's like a separate thing that I'm going to have to learn if I want to learn it. I don't know if I want to go that far as in building an editor. This is basically an FPS engine so far, which is good because I can get to the point of finishing this engine through the course and then maybe start to put together an FPS game or demo of some kind, something that I can just throw up on itch and people can have a play and see what they reckon. That'll be fun. So anyway, questions, guys, pop them in the comments. Have a great night.